All right, chapter 5 will be on chromosome mapping. So this is a very short lecture, but this chapter is a very difficult chapter, and the concepts of it are what really trip up the students. So we're going to actually spend the 3 classes to kind of work over problems and have the opportunity to kind of go over this in detail, but the lecture itself will actually be quite short. And the goal of this lecture is to move from a situation like we encountered in chapter 3. So this is an example of a dihybrid cross between 2 heterozygotes. And you should be familiar with this 9:3 to 3:1 ratio that you get from this. And in the activity for chapter 3, I had you sketch out kind of gene locations. And the idea is that you have 2 characters and they are controlled by genes on different chromosomes. So the gene A is on chromosome 1 and the gene B is on chromosome 2. Now we're going to switch to the point where the genes are actually on the same chromosome. So there's again 2 different characters. They're controlled by independent genes, but now instead of being on separate chromosomes, these genes are actually on the same chromosome. And so how do you handle that situation? And that's the point of this chapter. And this chapter is important for understanding that, but also understanding things like genotype relationships in closely related individuals. So this 23andMe, if you ever do that and you ever see the relationship between you and your brother, you and your sister, you and your parents, this chapter is going to help you understand where that all comes from. So by the end of this chapter, you should be able to explain why linkage distorts gamete production in heterozygous individuals, calculate the map distance between genes, establish the order of genes on a chromosome, and then use Punnett square to estimate genotype frequencies for linked genes. And so we're going to break this up into 2 different parts when we talk about 2 linked genes on the same chromosome, and then in part 2 we're going to expand this to 3 linked genes on the same chromosome.